Hi, good morning to one and all. In previous class, we discussed defects in rolling process. Okay, in this session, we will discuss about extrusion process. It is one of the manufacturing process in metal forming. Okay, coming to introduction about extrusion process. Extrusion is a process that forces metal to flow through a shape forming die. Okay, whatever the shape of the workpiece required, based on that we have to prepare a die. In this die, we have to pass the material by applying some force is known as extrusion process. Here, the metal is plastically deformed under compression is in the die cavity. Due to this, the metal will flow into the die under compression pressure. Due to this, some extrusion that produces only compressive and shear forces in the stock without any tensile forces, which makes high deformation possible without tearing the metal. Here, in this process, we are not applying any tensile forces on the material. Due to this, here only compressive forces will act on the metal. Due to this, the deformation is occurred. Due to this, here there is no tearing of metal occurs, as in case of rolling or remaining process. Next, it is a hot working process which, like forging, rolling, etc., uses the good deformability of heated metallic materials for shaping them. Here, this process can be done in the hot working process. Okay. Next, coming to working of the extrusion, that is, a metal billet is heated to appropriate temperature, is fed into the cylinder container of extrusion press. Okay, we have to heat the before the process. The metal is heated into the recrystallization temperature. It is placed in the cylindrical container, okay, of the extrusion press, and it is forced by action of a ram through a steel die whose orifice has the desired shape to produce the solid or hollow section. Based on the requirement of the shape, we have to first prepare the die. In that die, we have to pass the billet by applying some force is known as extrusion. First, we have to place like that. Next, the metal emerges from the die as a continuous bar which is cut to the required length. Here, the work material from the cylinder it will comes continuously. Whatever required length we have to cut at that point. Based on the requirement of length, we have to cut. Next, extrusion products are therefore essentially linear in character. In the sense, the shaping is confined to the cross section only. Here, in terms of length, we are not changing any shape, but the cross section only we can change by using the die. Okay. Next, the process is therefore eminently suitable for the production of a bar-like or tube-like objects. Okay. Example: rails or structural products and rods, bars. We can manufacture by using this process. Next, here observe in this diagram, it consists of die and workpiece is nothing but billet. Here some applying force on the billet. Observe, it is a die. A black color indicates the workpiece or billet. Here whenever we apply some force at the end of the billet is nothing but compressive forces. Due to this applying compressive forces, what happened here, the billet will move in this direction. Here whatever we manufacture shape of the die, the shape, the cross section will occur. Like that, the extrusion process will be carried. Next, coming to cross section of the object, that is, the cross section that can be produced vary from solid, round, rectangle to L shapes, T shapes, tubes, and many other different cross sections we made by using this process. Next, extrusion often minimize the need for secondary machining but are not the same dimensional accuracy or surface finish as machine parts. Okay, it is by using this process we can minimize the machining process after the completion of remaining methods. But the surface finish and accuracy we cannot achieve like machining process. Next, however, This process can be produce a wide variety of cross sections that are hard to produce cost effectively using other methods. Okay, by with these products cannot be achieved by using other methods. By using this process, we can reduce the cost. Next, extrusion differs from drawing in the metal is pushed rather than pulled under tension. But in case of drawing, there are some tensile forces are applied. But in case of this extrusion process, we cannot applying any tensile forces. We are applying only compressive forces, either in case of hot or cold process. These are the different cross sections can be prepared by using this extrusion process. Next, coming to cold extrusion. Here the cold extrusion is a process done at room temperature or slightly elevated temperature. Okay, that means here we are not increasing the temperature of the work part, is known as cold extrusion. The process can be used for most materials subjected to designing robust enough tooling that can withstand the stresses created by the extrusion. Here during the process some amount of stresses will applied, but in case of cold extrusion, here more amount of pressure is required to process the workpiece. Next, the cold extrusion can be used with any material that possesses adequate cold workability. Example, for lead, tin, aluminum alloys, copper, titanium, molybdenum, vanadium, and steel. These are the different materials can be processed under the cold extrusion process. Next, the typical parts which are cold extruded are collapsible tubes, aluminum cans, cylinders, and gate blanks. These are the different parts can be processed by using the cold extrusion process. Next, coming to advantages of cold extrusion process. In this process, no oxidation takes place because here not increasing temperature of workpiece. Due to this, what happened? There is no oxidation will occur. Next, good mechanical properties due to severe cold working as long as temperature created or below the recrystallization temperature. Due to the long we are continuously working on the material. Due to this, what happens? Some temperature will be increased due to the frictional effects. But it is not. It is below the recrystallization temperature. For that, there is no effect on the workpiece. Next, good surface finish with use of proper lubrications. Before the processing, we have to apply some lubrications. Next, coming to hot extrusion. Here, hot extrusion is basically a hot working process. Okay, it is done at fairly high temperatures of, that is approximately 50 to 75% of the melting point of the metal is known as recrystallization temperature. Okay, we can that temperature we have to do the workpiece. Next, the pressure can range from 35 to 700 megapascal. Based on this pressure, based on material to material, we have to change the pressure. Okay. Next, due to high temperature and pressure, its detrimental effect on the die life as well as other components, good lubrication is necessary. Due to the that amount of temperature and pressure, we have to provide a good lubrication facility. Next, principal variables. Here there are the principal variables, that is type of extrusion, the extrusion ratio, working temperature, speed of deformation. Next, the frictional conditions at the die and container wall. These are the principal variable we have to follow. Next, coming to typical parts of the extrusion process, that is trim parts used in automotive and construction applications, window frame members, railing, aircraft sectional parts. Okay, these are the different parts can be made by using the extrusion process. Okay, it is the difference between the cold extrusion and hot extrusion. Here, okay, first in case of here better surface finish and lack of oxide layer. Okay, first one is cold and second one is hot extrusion. Here mistake, the first column indicates the cold extrusion process and second is hot extrusion. Okay, here better surface finish and lack of oxide layers because it is without increasing the heat in cold extrusion process. But in case of hot extrusion, what happened? The surface is coated with oxide layers that is surface finish not compatible with cold extrusion. Next, good control of dimensional tolerance. There is no machining or very little machining required. But as in case of hot extrusion process, dimensional control are not compatible with cold extrusion process. We cannot achieve good dimensions and accuracy. Next, high production rates at low cost fit for individual component production. Here high production rates but process it fit for bulk material, not individual components. Next, as in case of cold extrusion, improved mechanical properties due to strain hardening. Okay, but in case of hot extrusion, there is no since processing is done hot, recalibration takes place. Next, in case of cold, tooling subjected to high stresses. Okay, but in case of hot extrusion, tooling subjected to high stresses as well as to high temperature. Next, tooling stresses are however lower than cold extrusion. Next, lubrication is crucial in cold extrusion process. Next, in case of hot extrusion, lubrication is crucial. Okay, the lubrication is in both cases is crucial. Okay, next coming to types of extrusion. Here direct, indirect, combined, hydrostatic and impact. Okay, these are the different types of extrusion process. Coming to direct extrusion process. In this, a forward or direct extrusion is sometimes known as Hooker process. Next, in this process, a ram forces the preheat billet through the die. Okay, next the die, the billet slides related to the container wall. The wall friction increases the ram force. Okay, due to this amount of we have to supply the lubrication. Next, a dummy block or pressure plate is placed at the end of the ram in contact with the billet due to the uniform force applied on the material. Next, the process can be compared like squeezing toothpaste out of a tube. Next, using this method, it is possible to extrude lip to 6 lengths. Okay, from one die. Next, the process is generally used to produce profile sections, thin walled tubular pods with heavy flanges. Okay, straight tubular shapes and halopers. By using this direct extrusion process, we can made by like these products. Next, typical products produced are bolt, screws, or stepper shafts can be manufactured. Next, it is the diagrammatic representation of direct extrusion process. It consists of chamber and ram. By using this ram, we have to apply forces on this material. Due to the application of force, whatever material placed in the cylinder, it will move throughout the extrusion. Whatever the die opening in that shape, the extruded part will be completed. Next, coming to indirect or reverse inverted or backward extrusion. Okay, it will also called reverse inverted or backward process. Okay, in this it is a process that forces the material confined in the cavity to flow in the opposite direction to the ram travel. Suppose we are applying some force on the billet. In that force, that is opposite to the force, the material will flow. Is known as reverse or backward. Here, the die moves in towards the billet. Thus, except at the die, there is no relative motion at the billet. Okay, that container interface. As a consequence, the frictional forces are lower and the power required for extrusion process is less than the direct extrusion process. Okay, next, in this practice, a hollow ram carries a die while the other end of the container is closed with a plate. Frequently for indirect extrusion, the ram containing the die is kept stationary. Here the ram is stationary and the cylinder and the container with the billet made to move. It is the reverse process of direct process. Next, backward extrusion is useful in forming a variety of cylindrical shapes such as nuts, sleeves and tubular rivets. Next, here it is the indirect extrusion. It is the chamber and it is the ram. Okay, here the ram is fixed but the cylinder will move in opposite direction. Due to this, the extruded rod will be formed. Next, coming to forward or direct extrusion, it is the difference between forward and backward. In forward, Here simple, but the material must slide along the chamber wall. But in case of backward, the material does not move, the die will move. Okay, here high friction force must be overcome in case of forward extrusion, but in case of backward, low friction forces are generated as the mass of material does not move. Next, high extrusion forces are required, but mechanically simple and uncomplicated. Okay, here 25 to 30% less extruding force required as compared to the direct extrusion, but hollow ram required a limited application. Okay, next, high scrap or material waste in case of forward, that is 18 to 20% is on an average the scrap will be developed, but in case of backward, low scrap or material waste, that is 5 to 6%. Okay, here there is very less scrap will be occurred in case of backward process. Next, coming to combined extrusion process. Combined extrusion process uses a combination of forward and extrusion process. Okay, forward and backward extrusion process in both we can use in combined extrusion process. Here the metal is confined inside a matrix between the lower and upper punches. Okay, like that we have to carry it. Next, the forces the metal to flow both up and downwards. Okay, the extruded part is lifted from the die on the upward stroke of the slide by lift out of the bed or the press. Next, some aspects of the combined extrusion process. It is a fast, it can complete parts in few steps, it can produce a large quantity with low unit cost. Okay, next, it waste little material, it can make parts with small radii, it required mirror tooling. Okay, these are the different aspects in the combined extrusion process. Next, coming to hydrostatic extrusion process. In this process, the chamber is filled with a fluid that transmits the pressure to the billet. Okay, which is then extruded through the die. Next, there is no friction along the walls of the container because we are using hydrostatic. It will minimize the pressure friction between the workpiece and container. Next, because the billet is subjected to uniform hydrostatic pressure, it does not upset to fill the bore of the container as it would in conventional extrusion process. Next, this means the billet may have a large length to diameter ratio. Even the coils or wires can be extruded, or it can made have a irregular cross section. Next, because of the pressurized fluid, lubrication is very effective and the extruded products has good surface finish and dimensional accuracy. Since friction is nearly absent, it is possible to use dies with very low semi-cone angle. Okay, like that we have to use with greatly minimize the redundant deformation. Next, the only limitation with this process is the practical limit of the fluid pressure that may be used because of the constraint involving the strength of the container. Okay, and the requirement that the fluid does not solidify at high pressure. Okay, it is one of the limitation. Next, observe, it is the diagrammatic representation of hydrostatic extrusion. It is the chamber. Next, it is the extruded rod, it is the ram. Here in between the ram and extruded bodies, we have to use hydrostatic fluid. Due to the application of force on the ram, it will forces the fluid whatever inside the chamber, that fluid exert force on the extruded part. Okay, like this the process will be carried. Next, coming to impact extrusion. Okay, it is a form of indirect extrusion and is particularly suitable for hollow shapes. Okay, it is usually performed on a high speed mechanical press. Okay, the punch descends at a high speed and strike the blank. Okay, extruded it upwards. Okay, like that the workpiece can be finished by using this impact process. Here the thickness of the extruded tubular section is a function of clearance between the punch and die cavity. Okay, like that we have to maintain the thickness. Next, although the process is performed cold, considerable heating results from the high speed deformation process. Due to this, some amount of heat will be liberated. Next, here impact extrusion is restricted to soft metals such as lead, tin, aluminum and copper. Due to this, high amount of force is developed on the material. Due to this, what happened? There is a failure occurred in the material. For that, we are not done impact extrusion process on soft materials. Okay. Next, here it is the diagrammatic representation of impact extrusion process. It is the die. Based on the requirement of shape, we have to prepare the die and punch. Here the metal is placed in between in the die. Whenever we apply punch on this metal, what happened? Here it is extruded in the gap between the die and punch. Based on that, the thickness of the metal will be completed. Okay. Next, coming to machines for extrusion process. There are different types of machines out there. That is both hydraulic and mechanical presses of horizontal and vertical configurations are used for extrusion process. We can use hydraulic and mechanical presses. Okay. Next, they should be capable of exerting high forces and their ramps. Okay, should have long strokes. Like that, we have to select the machines. Next, to reduce friction between metal and extrusion chamber, walls can be lubricated or used. It is necessary to reduce the friction in between the walls and material. Next, the dies or punches are made cold, good quality from good quality alloy steels, which are known as hot and cold die steels. Next, extrusion speed is in the order of 0.5 meter per second for light alloys and 4.5 meter per second for copper alloys. Okay, these are the speed of the material, metal to material. It will change. That is the extrusion speed. Next, coming to advantages of extrusion process. Here the tooling cost is low as well as cost due to material. Next, intricate cross section shapes, hollow shapes and shapes with undercuts can be produced by using the extrusion process. Next, the hardness and the yield strength of the material are increased. In most applications, no further machining is necessary by using the extrusion process. Next, coming to limitations of extrusion, that is high tolerance are difficult to achieve. The process is limited to ductile materials only. Extruded products might suffer from surface cracking. It might occur when the surface temperature rises significantly due to high extrusion temperature, that is friction and extrusion speed. Okay. Next, internal cracking might also occur. Due to these are the different limitations of the extrusion process. Next, these cracks are attributed to a state of secondary tensile stress at the center of the line of the deformation zone in the die for small extrusion ratio and large die angle. Okay. Next, the center of extrusion is not directly deformed, okay, but dragged along the stretching out of the surface material. Next, this generates tensile stresses in the core, which can lead to arrowhead failure in the center burst defects. Okay, these are the extrusion defects. Sometimes the surface of the extruded metal or products develop surface cracks. It is the one of the defect in the extrusion products. Next, this is due to heat generated in the extrusion process. Due to this, the surface crack will be occurred. Next, these cracks are especially associated with aluminum, magnesium and zinc alloy extrusions. Okay. Next, the extruded products can develop internal cracks also. These are variously known as center burst, center cracking and arrowhead fracture. Next, there are three principal extrusion defects, that is surface cracking, pipe and internal cracking. Okay, we will discuss one by one. Coming to surface cracking. If extrusion temperature, friction or speed is too high, okay, the surface temperature can rise. Okay, due to this, what happened? Surface cracking and tearing occur. Okay. Next, these cracks are intergranular, that is along the grain boundaries, usually are caused in hot shortness. Next, these defects occur especially in aluminum, magnesium and zinc alloys. although they may also occur in high temperature alloys. Okay. Next, this situation can be avoided by lowering the billet temperature and extrusion speed. We can avoid. Next, surface cracking also may occur at lower temperature where it has been attributed to periodic sticking at the extruder parts along with die. Okay, due to this, the surface cracking will be occur. Next, because of similarity in appearance of the surface of a bamboo stem is known as bamboo defect. Okay. Next, when a product being extruded temporarily sticks to the die line. Okay. Next, the extrusion pressure increases rapidly. Okay, here shortly thereafter, the product moves forward again and the pressure is released. Next, the cycle is repeated continuously, producing periodic circumferential cracks on the surfaces. These are the different conditions for formation of surface cracking. Next, coming to internal cracking. Here, the center of the extruded part can develop cracks called center cracking, that is central burst, arrowhead fracture. Next, these cracks are attributed to a state of hydrostatic tensor stresses at the center line in the deformation zone, the die. Okay, a situation similar to naked region in a tensor stress specimen. Okay, these cracks have been observed in the tube extrusion in the tube spinning process. Next, coming to that is loss defect pipe. Okay, the type of metal pattern in the extrusion process tends to draw surface oxides and impurities towards the center of the billet. It's like a funnel shape. Here the pipe will be occur. The defect is known as pipe defect or tail length. Next, as much as 1/3 of the length of the extruded products may contain this type of defect. Okay. Okay, these are the different products, that is surface cracking, internal cracking at pipes. Okay, the first one indicates the center burst and second one piping. Here observed, here the piping will occur. Next, surface cracking. Okay, thank you. It is about extrusion process.